So far in solving quadratic equations, we have used factoring, and the idea that a times b equals 0 means that either a equals 0 or b equals 0. And also we can find solutions to simple equations that look like this. A square equals some number. That means that if x squared is 9, x equals plus or minus the square root of that number. And this also applies to equations of this form. Now we're going to look at a technique called completing the square, which will eventually lead us to a general formula, the quadratic formula for solutions to quadratic equations. So we can use this technique to solve quadratic equations, and the idea is to make this part of the equation, x squared plus bx, into a perfect square, and then our equation can be transformed to look like an equation of this form. So how do we do that? Well, if we add b over 2 squared to x squared plus bx, then this is actually x plus b over 2 squared. So for example, if I have x squared minus 4x, this is b equals minus 4. What I'm saying is x squared minus 4x plus b over 2, which is minus 2 squared, should equal x plus b over 2, x minus 2 squared. And you can check this out. This is x squared plus 2 times minus 2 times x, which is minus 4x plus minus 2 squared. So we can use this trick to convert a quadratic equation into something of this form, a simple quadratic equation. How do I use this? Well, I take half of the coefficient of x, square it, add it to both sides of my quadratic equation. You must remember a quadratic equation is an equation, so to preserve equality here, if I add something to the left, I must add something, the same thing, to the right. So I add this square of half of the coefficient of x to the left, and this part now becomes a square, x plus b over 2 squared, and everything else is a constant. So now I've transformed the equation into x plus or minus a constant squared equals another constant, and I know how to solve that. Let's see how it works. Suppose I want to use completing the square to find a solution to this equation. Well, the prescription here is I take half of the coefficient of x and I add it to both sides of the equation. Half of this coefficient, half of b, is minus 3. And I square that and I add it to both sides. Now this part, all of this, I've completed the square. That's x minus 3 squared plus 12 equals minus 3 squared, which is 9. And now I know how to solve this thing. X minus 3 squared equals 9 minus 12, it's minus 3. And now I know that there are no real solutions, because no square of a real number can equal a negative number. So I can conclude that there are no real solutions to this equation. How about this? Well, the first thing I can do is pull out a 2 from every term here. Sorry, that's 4x minus 10 equals 0. And now I could divide both sides by 2, and I get x squared minus 4x minus 10 equals 0. Now I must solve this equation. I'm going to complete the square, convert it to something of this form, and then find the solution. You might want to pause the video and check if you can do that, and then look at my solution. Okay, so to complete the square, I take half of the coefficient of x, which is minus 2. I square it, so it's always going to be a positive number I'm adding, and I add that to both sides. This part should now be a square, so that's x plus half of the coefficient of x squared. And it's that minus 10 equals 4. Now I bring all of the constants to the right, and I get x minus 2 squared equals 14. And this means that x minus 2 equals plus or minus the square root of 14. I could write this as two equations, x minus 2 equals plus the square root of 14, or x minus 2 equals minus the square root of 14. And now x has to equal, well, I add 2 to both sides, it's 2 plus or minus the square root of 14. So I'm saying here there are two feasible solutions, x equals 2 plus the square root of 14, and x equals 2 minus the square root of 14.